Oh, so come back. I skip. So you can see here this is forming x minus x bar divided by s. So if this value is smaller than x bar, if the value is smaller than the mean, the z-score will be negative. But if the value is actually higher than the mean, the z-score will be positive, right? So that's what it means here. Back. So here we want to compare a baby weight and adult body temperature. So you can see this have two different units. When we say we compare them, we cannot just compare them by number because weight and body temperature are two different things, right? So you cannot just say compare because which number is higher. No, we have to compare the actual z-score. So the one that has a more higher z-score will be much more significant, right? So the 4,000 gram weight of a newborn baby among 400 weights with sample mean x bar equals 3,152 grams and a sample standard deviation s equals 5,693.4 grams. Now the temperature, adult body temperature, 99 degree Fahrenheit temperature of an adult among 106 adults with a sample mean of 98.2 degree Fahrenheit and sample standard deviation s equals 0.62 degree Fahrenheit, right? So we know the mean, we know the standard deviation, we know the actual x value. So the x value for this one will be 4,000 and the x value for the body temperature will be 99 degrees. Okay, all right, so I hope there is no issue. Right. So we want to calculate the standard deviation for, we want to determine whether the 4,000 gram weight and the 99 degree body temperature can be standard by converting, we have to convert them to z-score, and then we're going to compare the z-score, right? So 4,000 gram birth weight. So we use z equals x minus x y divided by s. And so you can see our x is 4,000 gram. And the mean was given to us. Everything's given. 3,152.0 gram divided by the standard deviation. So if you compute that, see here, the unit cancel each other out. So there is no unit. So this score here is 122. 1.22. Now for the body temperature, adult body temperature, we get the z-score, let's go 1.29. So you can see here which one is higher. The adult body temperature is much higher. So the z-score shows that the 4,000 gram birth weight is 1.22 standard deviation above the mean, and the 99 degree Fahrenheit body temperature is 1.22 standard deviation above the mean. So the one which the 99 degree Fahrenheit body temperature is more significant than, or more extreme than the weight, right? So because the body temperature is far above the mean and is more extreme value, a 99 degree Fahrenheit temperature is slightly more extreme than a birth weight of 4,000 grams. All right, it's more extreme. All right, so significant value are those. So as we mentioned, the values that are significant, same thing as range rule of thumb, has to be between -2 and 2. For the range rule of thumb, it has to be x minus 2 standard deviation, x plus 2 standard deviation. For the z-score is between -2 and 2. So if the value is not between -2 and 2, it is not as significantly high. It's more extreme, right? So you can see here from -2 and lower. significantly low values, and that means the data values are significantly low, and the value here significantly high. If it's 2 and high. The lowest Plattitell count is in the database is 75. Count for measure of 100 cell, right? Plattitell counts are measured in 1,000 cell, and that value significantly low? Okay, so this is another example, right? So we can also determine if it's significantly low or high. Okay, so let's we have the standard deviation 64.2, the mean is 239.4, and we are focusing on 75, right? X minus x bar divided by s, again, calculating standard deviation, 75 minus 2.39 divided 0.4 divided by 64.2, and we get negative 2.54. You can see this is negative, right? So this is below or above, because negative has to be below the mean, because you can see here the mean is much higher than the x value. As we mentioned, every time the mean is higher than the actual data value, the z-score will be lower, right? The Plattitell count of 75 converts to a z-score of negative 2.56. It's less than negative 2, so the Plattitell count of 75 is significantly low, right? It's very low. But not for lack of a better term. So now we're going to focus on percentiles. Percentile are measure of location donated by P1, donated by P1, P2, and P100, which divides a set of data into 100 groups with 1% of the value in each group. So the percentile again divide the data into 100 groups, right? And it determines the location of a value. Now, how do we find the percentile of a data value? Since the process of finding the percentile of data value corresponds to the particular data value x is given by the following, and you run the result to the nearest whole number. So that's the rule, you have to run to the nearest whole number. Percentile value of x. So you have the next value, you want to determine the percentile value. So you count the number of values that are less than x divided by the total number of values and you time by 100. So which means if your data set is not in any order, you have to put the data set in order, right? Once you put in order from least to greatest, then you can find the number of values that are less than x, right? So for instance, if you have data value 2, 4, 6, 8, 9, 10, and your x is 2, you are finding the percentile value of 2, of 6, for instance. So how many numbers are less than 6? So 2 is less than 6, 4 is less than 6. So that will be two values. 2 divided by total number of values. So 2 divided by 5, because we have 5 values, and you time by 100. And usually you'll be dealing with large numbers, not just 5 numbers. So this is an example, finding a percentile. And we have airport Verizon cell phone data speeds listed below are arranged in increasing order. Find the percentile of the data speed of 11.8 Mbps. So you can see here it's already ordered from least to greatest, which makes our life much easier. So our focus is to locate this 11.8. What is 11.8? So 11.8 is here. Now we need to count how many values are less than 11.8, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 here, 10 on top, that's 20. So 20 data values are less than 11.8. So you can see 1, 2, 3, 4, 5. So that's number of values 6. So we sorted the list of airport data speed in the table. We see that there are 20 data speed less than 11.8 Mbps, right? So we just count is 20. Now percentile of value of 20, of value 11.8 is 20 divided by the total values and you time by 100. And we get 40. So for instance, if you get 40, the answer was 41.2. so you just pick 42. If you get 41.4, you still pick 42, right? So P40, the data speed of 11.8 Mbps is a 48. So 48, it's like 40% percentile. This can be interpreted loosely as a data speed of 11.8 Mbps separates the lowest 40% of value from the highest 60% value. We have P40 equals 11.8 bps. So you can just write P40 is 11.8 bps. That means 20% of data values are less than 11.8 and 60% of data values are greater than 11.8. Now there are some notation we need to remember. N is the total number of values in the data set. K represents the percentile being used for 25 percentile. K equals 25. Locator is L is a locator. It gives the position of the value. For the 12 value in the sorted list, L equals 12. If the location, L tells the location. For the 12 values, L is 12. For the 21st value, L is 21st, and so on. PK is the K percentile. For instance, if P25, 25 is the 25th percentile, right? So PK stands for this numbers here. All right, so the value of PK, so now you pick 22, the value of PK is the LF value. So counting from the lowest. So the value of PK will be the 22nd value. So you look at the table, you count when you get to 27, you just pick PK, right? We're gonna get to some example. Now, if L is a whole number, as I mentioned, you're gonna pick the KM percentile, the midway between L value and the next value in the sorted set of data. So if your L is 22, you're gonna pick the 22nd value plus the 23rd value and you divide it by 2. Right? So that's what you do to find PK. All right. So we have the sorted data here. K is 40 and N is 50 because we have 50 data value. L is K divided by 100 times N. So we want to find P40, right? So we want to find the value of P48 percentile. So that's P40, right? So which means K is equal to 40. So 40 divided by 100 times 50, N equals 50. So you get 20. So now we see we get a whole number. What do? We cannot just pick, say L equals 20 is here. What we do is we're gonna pick the 28th value that's occupies the 20th place and the 21st place. We add them up and divide. So since L is a whole number, we proceed to the box located at the right, this box. All right, so we're gonna add the 20th and 21st number. So the 20th value in the table is 11.6 and the 21st value is 11.8. So the value midway between them is 11.7. So which means P40 equals 11.7 Mbps, right? P40, for this means 40% of data values are below 11.7 and 60% of data value are above 11.7 Mbps. Now the next thing we need to learn is the quartile. They also are the measure of location. So we denote quartile by Q1, Q2, and Q3, which divide a set of data into 4 groups with about 25% of value in each group. So 25, then 50, then 75, and then 100. So quartile, Q1, Q2, Q3, and there is no Q4. So Q1 is called the lower quartile. Q2 we can call it the median of the set of data, and Q3 is called the upper quartile. So Q1 is the first quartile, same thing as P25. It's actually P25. It separates the bottom 25% of the sorted data value from the top 75%, right? So the second quartile is same thing as P50. It's called the median also. We separate the bottom 50 of the story value from the top 50. Third quartile is P75 because we're going by 25%. Separate the bottom 75 of the story value from the top 25. Okay. So there are, all right, so you can read this question on your. So there is also an interquartile, which is Q3 minus Q1, and semi-interquartile, which is Q3 minus Q1 divided by 2. You don't need to memorize this formula. And mid-quartile range is Q3 plus Q1 divided by 2. Those are our values. So we're going to learn how to find Q1, Q2. We already told you Q1 is P25, Q2 is P50, and Q3 is P75. And we know how to find P25, P75, P50. But we go over it again. 10 minus 90 percentile range is P90 minus P10. So those are just basic computation. What about that? Now, the next thing we need to remember, because we are going to use those, use Q1, Q2, Q3 to construct the box plot. So there are 5 things, this concept you need to remember, 5 number summary. All right, so 5 number summary, just here the minimum data value, and the first quartile Q1, the second quartile Q2, the third quartile Q3, and the maximum. So that's called the 5 number summary. If someone asks you to determine the 5 number summary, first you might just start with the minimum and the maximum. Those are easy to find. And then you focus on the Q1, Q2, Q3. Again, this is P50, P25, P50, P75. All right, so finding the 5 number summary. Use the Verizon Airport data speeds to find the 5 number summary. So again, we have the minimum, we have the maximum. So it's already sorted from least to greatest. So it's easy to find the minimum and maximum. So you find those. So we have 3 more things to find. Find next Q1. Q1 is 7.9. It's 25% of data. So there are ways to find. You can use the L formula again, right? How K L the located, L equal K over N times 100, right? So you can use that to, so for Q1, your K will be 25. So 25 divided by N times 100, right? So we have 50 data value. So you do 25, 1 second, 25 divided by 50, divided by 50 times 100. So there are ways, or different ways to find those Q1, Q2, Q3. You can use the median, and it's very easy to find this, right? So again, you can use the P25, P50, and P75. Again, for P25, K is equal to 25, and then for P, so K is 25, so you do, again, let me just guide you on that quickly. So you do 25 divided by 50, which is 0.45, times 100. So you get 50, how do we get 50? 1 second. 25. No, so it's L is equal to 25 divided by 100 times N. So you time by N, so times 50, right? So L 25 divided by 100 times 50. So you get 12.5. So you pick 13. So when you get L, you get 12.5. You round it to the nearest whole number. So that would be 13 value, so which is 7.9. For Q2, you do 50 divided by 100 times 50. So you get 25. So you see when you do that, you get 25, which is a whole number. So you have to pick the 25th and the 26th number and you divide it by 2. So when you divide it by 2, so you're going to get 13.7 plus 14.1 divided by 2, and you get 13.9. So you get about 13.9. Yeah, my computation wasn't correct. Now Q3, you do the same thing. So you get 75 divided by 100 times 50, and then you get 21.5 again. So the private number summary is therefore 0.8, 7.9, 13.9, 21.5, and 77.8. So you run this to this is rounded 7.8 to 7.9. Okay, so 0.8 is the minimum, right? The lowest number, and then the Q1 is 7.9, Q2 is 13.9, and Q3 is 21.5, and the maximum is 77.8, right? So box and whisker plot. So we use Q1, Q2, Q3 minimum maximum to draw the box and whisker plot. It's very easy. So we use a box plot to graph the basket and whisker plot. So construct the line segment extending from minimum data value to maximum data value, and you construct a rectangle extending from Q1 to Q3, right? And draw a line in the box at the mid value of the Q2 median. So if you have this data, you want to construct the basket. So you can see here the minimum is here, the maximum is here, and the box start from Q1, so 7.9 is an estimate, and Q2 is a medium, the median. So the box, you draw a line from the median, and Q3 is here, but you have to label it. You don't. It's already labeled. You have to make sure you follow some unit. So you see this is 0.8 here, and this is 7.8. So you have to actually respect the unit. Okay. Yeah. So a box plot can often be used to identify skewness. Distribution of data is skewed if it is not symmetric and extend more to one side than to the other. So the box plot can show that. So identify outlier for modify box plot, find quartile Q1, Q2, Q3, find the inner quartile. So these are formulas that we just went over. So, should just competition. So we also have modify box plot, which is a regular box plot constructed with this modification. The special symbol such as an asterisk or point is used to identify outlier defined above. A solid horizontal line extends only as far as the minimum data value that is not on the outlier and the maximum data value that's not an outlier. So this